Hello everyone. So let's see the unit impulse signal. First, we know that the unit impulse says that it is 1 at the 0. At the 0, the signal is 1. Elsewhere, it is 0. So then space. I need from -3 to 3. And for example, I need 1001 points. So how will it be? This is -3 to 3, the x-axis, and between it is 1001 points plotted. Okay, so now I will be writing the points, which will be at the y-axis. So from the first 500, of course, will be zeros, and 0 will be 1, and then the others are zeros also. So again, 500. Great. So now plot the x, which I named it as t, and the y, which I named it as y. And for example, I also want the line width to be 2.5, line width to be 2.5. Okay, great. And the axis, I want to begin from the first thing till the end. This is the x-axis, and the y-axis, I want it to be multiplied by 1.5 times the minimum of y and 1.5 times the maximum of y. Okay, and now let's see. I forgot over here anything. Yeah, the brackets. Oh, sorry. Okay, we could label it also the x-axis. X label. I wanted, for example, the time. The x-axis is the time, right? And the y label, the amplitude. Okay. And then the title would be unit impulse signal, right? And then let's run the code and see. Yes, we did it. Over here at the 0, it is 1, whereas elsewhere it is zeros. And we said that we want the x-axis from -3 to 3 and the y-axis from 0 to 1.5. You will ask me why till 1.5 it's drawn. Because we said 1.5 times the minimum and 1.5 times the maximum. 1.5 times the minimum. What's the minimum over here in the y? 0, right? So 1.5 times 0 is 0. 1.5 times the maximum. What's the maximum over here? It's only 1, right? The other elsewhere is zeros. So 1 is the maximum. So 1.5 times 1. It's 1. Okay. Okay, great. Let's see another example. Now I want the x-axis to start from -3 to 3. Okay. Again, from -3 to 3. Okay. And the axis, I mean the y's, you can name it as what you want. Whatever you want, you can name it. So 0 from -3 to 3, how many points? -3 to 1, 3 points, and 1 to 3, 3 points, and the 0 means 7 points. Okay? So 1 and 3. Okay. Now I want it to be discrete, not continuous. So stem. Use stem. And I want the line width to be 1.5, for example. Okay, the axis. Over here I want to write it in another way, and this will be the sticked way, which is easier and it will be in your mind always. So minimum of the x, which is n, and the maximum of the n. Again, this is the x, okay? The y minimum of the y and maximum of the y. Okay, I could also multiply this by what? By 1.5. I want it to be plotted till 1.5, for example. Okay, and then x label time and the y label. We can write x of n. Okay, in the title it would be unit impulse signal. Okay, let's see how is it going to be. CLC to clear it. And now let's go. What's AX? Okay, there's something wrong over here. What's AX? Okay, I have made a mistake here. Okay, MAX. And over the 0 it's 1, and elsewhere it's zeros, discrete as it is shown. Okay, we could also write it this as before. Y is equal to, what did I do? Zeros from 1 to 3 and 1, then zeros 1 2 3 again. Okay, this is the same thing. Okay, same thing. So now let's see the unit step. For example, I want to write from -10 to 10, the x-axis, from -10 to 10. Okay, and the y, you know that a unit step is from 0 to greater than 0, it is 1, else it is 0. So 0 or greater than 0, it is 1. Great. So zeros from 1 to 10, okay, and ones from 1 to 11, because the zeros also counted 0 1 2 3 4 5, till 10. Okay, 11 numbers, 11 points, right? It's now 10 plus 10 is 20, plus the zeros, 21 points, and 10 plus 11 is 21 points, so you are correct. Now plotted stem by writing stem, which is discrete. Okay, then n and the t. Okay, and the width, I want it, for example, to be 1.5. Okay. Okay, and you could write the x label time and the y label amplitude. Okay, the title could be unit step, signal, right? Okay. And the axis, which is the n, the minimum of n, and the maximum of n, this is the x. Then the y, which is the, for example, I want to multiply it by 1.5 times the maximum of, first we write the minimum of the t, and 1.5 times the maximum of the t. Okay, here I forgot this. Okay, and now let's run it. CLC. Great, and here it is. 0 greater than 0 is 1, else it's zeros. Okay, we could also make grids. So how to make grid? Let's check. There's no grids. Wait, I deleted it. Grid. That's the grid. We can make the grid small also. So grid minor. Okay, as it's shown over here, small columns and rows. Okay, there's also another way to write the axis, which is x lim. Okay, x n of 1. Okay, and great. Now the y lim, which is 1.5 times the minimum, which is t, and 1.5 times the maximum, t. Okay, now let's give it a try. And here is it. Here it is. So it's the same. You could use the x lim or y lim, or the other one, which was the axis. Okay, great. Okay, now let's see how the unit ramp signal will be. N is equal to ln space, I want from -10 to 20. I want the points will 31. Okay, second thing, I want stem. This is unit ramp signal, so x will be equal to 1 or y or whatever name you want to name it. Okay, so stem will be the n and the y, and the line width would be whatever you want. I would say 1.7. Don't forget the single quotation. Okay, then I would name the x label as n. Okay, and the y label as x of n. Okay, now the title would be unit ramp signal. Okay, then x lim n start from the beginning, 1, and then till the end. Okay, and the y lem minimum of y and maximum of y, sorry. Okay, and that's all right. Is there something wrong? And yeah, the bracket. Okay, here there is same mistake. Okay, now it should work. Oh, sorry, I forget the I over here. What's wrong? Okay, then L. Take care of those mistakes. Now let's see it. And here it is. Okay, now if I don't want to use the y lem, I can use the other way, as I say before, the axis, and then you would say the minimum of n and the maximum of n and the minimum of the y times 1.5, for example. Whatever you want to write, you can write y times 1.5. What means this? Means the minimum times 1.5. The minimum of y means the lowest number of the y will be multiplied by 1.5, and the greatest number will be multiplied by 1.5, and this will be the y-axis. Okay, great. Let's see, would it be the same thing? Of course. Yeah, of course it will be the same thing. It starts from -10 till 20 and -15 till 30. Okay, now let's see how to draw the exponential signal. Okay, let's say a will be 0.1. the n will start from -10 to 20. And for example, I will say the x1 would be the exponential of -1. This is the decaying signal times the a times the n. Okay, yeah, stem the n, the x1. This is the x-axis, this is the y-axis. Okay, don't confuse. Let's run this, and this is a exponential decaying signal. Okay, what if I want also a exponential growing signal? Instead of negative, we'll just type 1. Okay, comment this. Let's see this. As it's shown, it's growing signal. This is the exponential growing signal. I want those two, the exponential growing and the decaying, on one graph only. How would I do this? It's simple. I would say over here, what? The subplot. You remember? Subplot. I want 2 rows, 1 column, and this is the first index. Okay, over here, subplot, 2 rows, 1 column, and the second index. Now let's run this. Oh, I forgot to write for the x2. This is the x1, x2, and yeah, that's correct. Is there something else wrong? No. Let's see. And here it is, first and the second. We could label also as x label, y label, and the title. Okay, this is the one. Is where is the growing? No, this is the. Oh my god, there's something wrong. Oh yeah, I forgot here to write x2. Now it will work. Yeah, as it's shown. Okay, this is the decaying and this is the growing one. Okay, thank you, and that's it for today.